Okay, so let's talk about cold fronts. They're very dramatic. They are the stars of the weather show. I got out some great ones for you to look at here, and just really cool stuff. So you can have the big gray ominous clouds. You can have the rotor clouds that just move in with the cirrus clouds above them. Very, very dark back there. Very dark. And you could have a shelf cloud that comes in underneath an anvil cloud that is up at the stratosphere. Very exciting there. And then you could have this absolutely perfect line, amazing, that says, here is the cold front coming in. Cold fronts are very dramatic. I hope that you will look at the video that I put on Blackboard. That is really exciting. The first minute, you're kind of bored, and then literally all hell breaks loose. So I hope that you'll get a chance to look at that. Let's talk about why these cold fronts are so dramatic and how they work. Like we said, fronts are a transition zone between two air masses of different densities, a warm air mass and a cold air mass. We talked about the lower density of the warm air mass, the higher density of the cold air mass. And I'm going to bring to you several analogies so you will never forget your cold fronts and how they work. My first analogy is one of my favorite ones. It says to think of a cold front as a huge Cadillac Escalade. Just massive, just so dense. And to think of a warm front, which starts with a W, as a Volkswagen, right? And the little Volkswagens are just, little Beetles, just little cars. And to think of these two meeting together and running toward each other, which one is going to win the battle? Well, you know that the Cadillac Escalade isn't stopping for anybody. And so what happens here is when the Cadillac Escalade comes barreling in at 26, 30 miles an hour, and the Volkswagens are trying to get away, but they're going at about 15 miles an hour. They can't go that fast because they're kind of buoyant. Then the Cadillac Escalade is just going to run right in, run right over and throw them up in the atmosphere. Just run right over them. So that's a really good way to think about a cold front, because that is exactly what happens in a cold front, and it is highly dramatic. Another analogy to think about is sliding your hand. I'm going to be the opposite here. Good. Okay. Sliding your hand along a table, and the table feels kind of rough, and so you kind of come into some friction, and your hand starts to ball up and become kind of thicker and thicker and thicker. So if you want to think of it that way, you can think of the friction along the ground, because this cold air mass is so dense it's hanging out by the ground, and it just gets thicker and denser the more it rolls out of Saskatchewan. It really becomes a very powerful force. So you can think of that as another cold front analogy if you choose. When you look into a map of that, we can translate the cross sections that we just showed you of the big Cadillac Escalade that's cold and the little warm Volkswagens that go flying up in the atmosphere. We can translate that cross section into a surface map that has the cold front, that now only has the blue triangles on it, because the cold front is making the move, and the cold air mass is running the show here. This is not a stationary setup. This cold air mass is on the move. We're going to be doing a lab to understand how you can tell if the air mass is on the move. But in general, the way you tell if an air mass is on the move is by watching it over a series of hours. And you plot the isobars, and you see the isobars moving, and you know that the cold air mass is on the move. So we'll be doing a lab about that and seeing that in effect. Here is back to the cross section again. Here is the Arctic air mass pushing the polar air mass through Saskatchewan, and the warm air mass is going to go up and over this Cadillac Escalade, right? So just to get you back into the 3D if you need it again. The cold air masses are more dense and therefore more stable, and they are replacing the warmer, sometimes moist air that is unstable, because we know that unstable atmospheres have a lot of convection and a lot of rising air parcels. I'm going to take that out of there. Cold front temps in the spring. Let me talk to you a little bit about this 3D section. And I have a guy here who plays banjo, and you can pretend he's you, just hanging out on the front porch, watching a cold front come at him. And where he's at, looking at the temps in the springtime out on his front porch, it's 55 degrees where he's at. Feels good. And this cold front is coming toward him. So we are going to trace how this cold front impacts him as it comes toward him. As this cold front comes at him, the temperature gets lower because there's a whole lot of cold air coming at him. And the temperatures at the front are quite a bit lower, 39 degrees Celsius. Behind the front, 42. In the heart, in the mass of the front, it's 25. And this is a really important point. You see how this is a Cadillac Escalade, but even a Cadillac Escalade has a front section and a section where the center of gravity and the center of mass is. There's a center of mass back here that has more cold air, and therefore that's the coldest air in. And this will be closer to the front. It'll be a little bit warmer, but certainly it'll be a cold front with a lot of cold air behind it. So that's looking at the temperatures as the cold front is coming at you. You can also look at, another way of looking at this is looking at the cool air that's nearest to the front from the cold front. The colder air that's in back, the coldest air from the Arctic air mass is in back. That's where the majority of the air mass, the matter, is, and that's holding most of the cold air in the top of this dome with all the mass underneath it. If we look at the wind direction, we see winds that are from the southwest in the warm air mass. And that makes sense. They are often coming out of the continental tropical areas out of Mexico, or they are coming out of the, if you are in Arizona, they are coming from the maritime tropical out of the Pacific. If you are in New York City, they are coming from the southwest, they're coming from the Gulf of Mexico, which is southwest of us. So those winds are typical warm warm air mass winds. And the wind direction from the cold air mass is typically from Canada and is typically a northwesterly wind, that is from the northwest. So it's really important to know those differences in temperature and differences in wind direction because they help you, along with the isobars, to find the front and to find which air mass is winning the battle. When you look at cloud cover, that's another clue about cold fronts. Cold fronts generally have very high cirrus clouds coming in a day or two in advance. Then we know the cloud cover gets lower and gets lower. So you see that there will be altos after the cirrus, and then the stratus will be in the back, and you'll even have sinking stratus that come in with the cold front. Right? I've labeled them for you there. So cirrus, cirrostratus, cumulonimbus, altocumulus, and here you have stratus back here. When we look at the area of a cold fronts move fast. The dense air moves it, like we said when we were talking about the Cadillac Escalade and the Volkswagens, The dense air will move about 30 miles an hour, can move in upwards of about 40 miles an hour. And the warm air mass is kind of, 15 miles an hour. Not very much going on. So these areas of the cold air mass, 50 kilometers, so we're talking about 30 miles there. So 30 miles from the frontal line back into the heart of the cold air mass, the coldest air, about 50 kilometers, 30 miles or so. Cold fronts are dramatic and they're rapid. You can look over this later. You can look over this in your text. It's a really good idea to take a look at it. I'm not going to go through it with you. That's why I went through all of the drawings with you, but I want you to pay attention to this for temperature and winds and clouds and precipitation. All right? In fact, let's go back to precipitation for 1 second. What we are noticing with a cold front is that it's generally rain. And you were expecting snow, weren't you? But guess what? The warm air rides up so that is producing the condensation. It will fall through cold, but in many cases, a cold front is rainy because of the warmth of the air above it. All right? So you learned about warm clouds and cold clouds. You learned about warm precipitation processes by collision versus cold precipitation processes in cold clouds with ice crystallization. Now it's all coming all together for you. We went over that, and I will see you on the other side more about cold fronts. It's cool stuff.